Alrighty, so it says quiz, but it's really not. It's just kind of a check-in. Um, so yeah, we're basically just going to go through and pick up some extra information and try to get some extra knowledge on. Yeah, I mean by now we should be pretty solid with congruent triangles and all those other different operations. So yeah, let's just go ahead and get it started. Um, yeah. So if G is the midpoint of AB, classify each triangle by its angles and sides. All right, so really quickly, G is the midpoint of AB. So that means that those sides are going to be equal also. All right. Let's see, CFE. So CFE, I see a 90-degree angle here on CFB. Well, if CFB is 90 degrees, that means that CFE is also going to be 90 degrees. So I mean, that kind of tells me that it's going to be a right triangle. So by angle, it's going to be right triangle. And then by side, that definitely looks like a scalene because, well, I mean, I know the Pythagorean theorem, and I know that it has to be a scalene. So, so I know it has to be scalene. So I'll just go ahead and fill these in here. So I have to categorize each one of these by angles and sides, so I just filled in angle sides for each one of the answers here. All right, so BEC, so I've got BEC. All right, so with this one, I've got 5. This side is 8. Um, this hash mark means that it's 6, but hello. So from F to E is 2, so that length is 2 from F to E. But that little hash mark means that it's length 6. So 6 and 2 is 8. If this is 8, then that means that I've got two sides that are of equal length. And so that means I've got by sides an isosceles triangle. And by angles, I've got it'd have to be an acute triangle. It would have to be an acute triangle because all three of the angles are acute, but they aren't equal to each other. I don't have a right triangle. I don't have an obtuse triangle. They're not equilateral, so that's what we've got to work with. BFG, equilateral. And side, same. Point B, FG. I've got 3 sides that are the same length, so yeah, we're fine. And then GAF, again, triangle G to A to F. I started out by noticing that G is the midpoint of AB. So if G is the midpoint of AB, that means that if this is 6, then that is also 6. So if this length is 6, and this is 6, and this is 6, that means that I've got two sides that are equal to one another. So as far as sides are concerned, this is isosceles. As far as angles are concerned, that is definitely an obtuse angle, so it would be an obtuse triangle. All right. For this one, uh, for this one, I'm on the fence because part of me wants to send it to Desmos, but the other part of me doesn't. So we'll see how things pan out. For now, we're just going to skip it and move forward. Actually, you know what? Yeah, we are going to skip it. So because I don't want folks on the iPads working through these. All right, doing some more of these puzzles. I'm starting to like these puzzles. Starting to like them. All right, so angle 1, so it's part of a smaller triangle, but I've got 2 of the 3 angles in this smaller triangle. So I'm going to go 180 minus 72 minus 57. That's going to give me angle 1, which is 51. Um, this is going to be one of those ones where you don't necessarily solve it in order, but you solve it in the order that you can get the angles. Not necessarily in the order that you can get the angles, but in the order that you can find the angles in. And so I can get angle. Actually, I can get angle 2 right now. 72 and angle 2 add up, make 90. So because they're complementary. So angle 2 so 90 minus 72 gives me 18. So we're good there. 57 minus 3, uh, not 57 minus 3, 57 and 3 both give me, 57 and 3 are both supplementary angles. And so I can just go 180 minus 57. That gives me, angle 3 is 123. And so now I've got a couple of different options for angle 4. I know that angle 1 is 51. I know that this is 90. I can solve for angle 4 that way. Or I've got angles 2 and 3. I can subtract from 180 and solve for 90 that way. So what I'm going to do is I'm going to subtract angle 1, which is 51, from 90. Because if I'm trying to solve, because if the total triangle is 180, and I already have 90 accounted for with this right angle, then I only have to account for 90 degrees between angle 1 and angle 4. That's going to equal 39. And just to verify, be 100%, let's go with 180 minus angle 2, which is 18, minus angle 3, which is 123, and I get 39 again. Sweet. So I am right. I'm doing well so far. All right. On to the next puzzle of angles. Alrighty. So with this one again, it's well, all right. I can see how I want to. I'm going to lay off the supplementary for this one. I'm going to use the external angle theorem instead for this one. And normally I would use the supplementary angle property, find angle 1, but instead I'm going to use the external angle theorem, and I'm going to find number 2 first. So the external angle theorem is, if you have an external angle for a triangle, which is what 129 is, that is equal to the opposite angles of the triangle added together. So 129 minus 95 should give me the measure of angle 2, which is 34. And so 180 minus 95 minus 34 should give me angle 1, which is 51. And 129 plus 51, doing quick mental math, gives me 180. So if that would have been that's the perfect supplement for it. All right. Looking at angle 3, angle 3 is a vertical angle to angle to 95. So they're perfectly equal. So that's working out pretty well. So for this one, I've got 95 and 47. So 180 minus 95 minus 47. So number 4 is going to equal 38. I cannot put into words how desperate I am that you all don't remember any of these. So with angle 5 and 47 are vertical angles, and so they're going to equal, so they're going to be equal. And once again, I've got an external angle, and I can solve for angle 6 with 121 and 47. But instead, I'm going to solve for angle 7 using the supplementary angle. So 180 minus 121. So angle 7 is going to be 59. And so 59, so I'm going to take 180 minus 59 minus 47. That's going to give me 74. And that is going to be the final, that's going to be the final number, the final answer, for that particular drawing. All right. So for this one, we've run into a couple of these problems in the past, once or twice, uh, possibly more than that. So again, whenever you're calculating the angle sums of a triangle, what you're going to do is you're going to take you're going to combine like terms. You're going to focus on combining like terms and setting them equal to 180, because if you combine the internal angles of every triangle, you're going to get it equal to 180. So in this case, I've got 13 plus 3 plus 5. So 13 plus 3 is 16, plus 5 is 21. So 21x plus 2 minus 4 is minus 2, minus 7 is minus 9. That's going to equal 180. So 21x minus 9 equals 180. Alrighty, here we go. I'll get it even centered in frame. So 21x equals 189. 189 divided by 21 equals 9. So there we go. For this next one, we are going to, pray you forget it, and use the external angle theorem. So with the previous one, we relied on the fact that when you added all of these up, they equaled 180. And so this plus this plus this equaled 180 because that was the total internal angle sum. With the external angle theorem, all right, there we go. With the external angle theorem, we know that if you have an external angle, which is 19x minus 18, as I mentioned before up here when we were solving for angles, it is going to equal this angle plus this angle. And so what that means is we're going to take this angle, whatever it is, we're going to add it to this angle, whatever it is, and we're going to set it equal to this angle. So that means that we're going to get 19x minus 18. We're going to set it equal to, and again, I'm just combining like terms, 7x plus 10x, so that's 17x. And then plus 1 minus 9, so that's minus 8. And, yeah, that's it. That's 8. So I'm going to move everything around, so that gives me 2x. And then plus 18 to both sides gives me 2x equals 10, x equals 5. So there we go. Oh, this one does have a second page, though. All right. So, all right, this one's not too bad. If ABC is equilateral, solve for x. All right, so the key feature about equilateral triangles is that the sides can be anything, but whatever the sides are, they're equal to each other. That's no big surprise. But the big thing you got to remember about equilateral triangles, more than anything else, is that their interior angle measurement, their individual interior angle measurement is always, always, always going to be 60. So that means 8x minus 44 equals 60. They are not mysterious. I was going to say equilateral triangles are not mysterious objects. They are not difficult objects. They are not complex objects. Yep. That's yeah, that's it. I just did a calculator on the other side, so we're in good shape there. So let's see. If RST is isosceles, find the measure of angle S. All right. Well, this one is a little bit different. This one is a little bit different. It's actually going to require a couple of different steps. All right. Okay. All right. This is my compensation, I will call it, for putting up with equilateral triangles. So we're going to have to go about this a couple of different ways. So we're going to have to go about this with a couple of different steps. So RST is isosceles. We have to find the measure of angle S. So we have to find the top of the triangle. The thing is, because it's isosceles, these two angles are going to be equal to each other. Normally, I wouldn't say that we go by the this is what it looks like argument. But if you're told that something is isosceles and you have two really, really long sides compared to a third, you can kind of say, okay, well, these are the two congruent sides. Again, I wouldn't want to write a paper I wouldn't want to write a paper based on that, but for where we are in high school, that's probably okay. So what we're going to have to do is we're going to have to solve for x. Then once we solve for x, we're going to have to feed x back into one of these in order to get an angle measurement. Once we get the angle measurement, we're going to have to multiply it by 2 because that's going to represent these two angles. Once we get these two angles, we're going to subtract them from 180. And whatever that number is, that's going to be s. So again, multi-step process. So let's go ahead and get started. So I'm going to have 15x minus 31. And because it's isosceles, I'm going to set that equal to 9x plus 11. All right. So again, combining like terms, I'm going to move everything around. So that gives me 6x equals, let's see, 31, so that's 42. So x equals 7. All right. So x equals 7. What I'm going to do is I'm going to feed it into 9x plus 11. So 9 times 7, 63 plus 11. Okay, so each one of these is going to be 74 degrees. So what that means is I'm going to take 180. I'm going to subtract 74 twice. And what that leaves me with is 32. And there we go. That's the final answer. All right. In terms of complexity, it's right up there, but yeah, I can get behind that. That's pretty. I like that. Here we go. All right. In PQR, if measure of angle P is 14 less, all right. I don't care if we need it or not. We are always going to draw our triangles. If measure of angle P is 14 less than 5 times x, so 5x minus 14. Q is 5 less than x. And R is 9 less than twice x, so 2x minus 9. Find x in the measure of each angle. So this is just like the one of the this one. Except once we find x, we're not stopping. We're plugging it back in and finding each of the angles. All right. So that being the case, yeah. So again, we're combining all the like terms and then setting them equal to 180. So I've got 5 plus 2 plus 1, so that's 8x. Minus 14 minus 9, that's minus 23. Minus 5 is 28. Equals 180. So 8x equals 180 plus 28, which is 208. So x equals 26. All right. It seems a little big, but we'll see how it goes. So angle Q I can do offhand. So angle Q is going to be 21 because it's x minus 5. Second one, angle R is 2 times 26 minus 9. That's going to be 43. Then P is going to be 5 times 26 minus 14, 116. Okay. Now, as I mentioned in one of the previous worksheets, the good part about working with angles is that if you want to check your answer to make sure that you got everything correct, the easiest way to do it, 116 plus 21 plus 43, whew, if you get 180, then you got them right. Or at least if you're wrong, you got them wrong well enough to get close. You got them wrong well enough. All right. So let's move on to the next one. JKL, so J's always look like T's. Okay, 7 less than ML. Ooh. Measure of angle K is 21 less than twice ML, so L minus 21. Yeah, I've run into one of these before. I like these ones. Find the measure of each angle. So with this one, instead of solving for x, we're basically just solving for one of the measure of the angles just immediately. So yeah, let's go ahead. We're not really changing the plan. We're not really changing the process. We're still taking everything that we have, combining like terms, and then setting them equal to 180. The difference is that now the like terms that we're adding together are all in terms of the measure of angle L. And so in this case, and I guarantee this is where people are going to get tripped up. I've got 2 times the measure of angle L plus the measure of angle L, so that's 3 times the measure of angle L plus the measure of angle L itself. So it's going to be 4 times the measure of angle L, and then combining like terms minus 28, that's going to equal 180. So let's see, 180 plus 28 is 208 divided by 4. So the measure of angle L is going to be equal to 52. Now let me see what, I'm kind of curious here. So 180 plus 28, I'm curious what it is divided by 3. Oh yeah, that should, if it's divided by 3 times the measure of angle L, it's a huge decimal. So that should be a pretty big clue that something isn't right. Anyway, measure of angle L is 52. For J, J is the measure of angle L minus 7, so that's 45. And then for K, is 2 times L, so that's 2 times 52. 104 minus 21 is 83. Okay, and as ever, we will verify this. 45 plus 83 plus 52. Whew, 180. And we are in good shape. All right. So in BCD, BC is congruent to BD. All right, so we're back to isosceles triangles. And the reason that we always want to draw, this is the main reason that we always want to draw the triangles first. So I've got BC congruent to BD. I see that I've got B in common with both of the points. So that means I'm going to put B at the top of the triangle, then C, and then D at the bottom. So there we go. Measure of angle B is 13x minus 35. All right. C is 5x minus 19. Yep. And then D is 2x plus 14. Find x and the measure of each angle. So the reason that I draw these the way that I do is because it's a standard set way that eliminates the possibility of error when it comes to me setting up the equalities for this isosceles triangle. I know that BC equals B is congruent to BD, so BC congruent to BD with isosceles triangles, the angles opposite the congruent sides are also congruent. So when it comes to setting up the isosceles, when it comes to setting up the equality, I know 5x minus 19 equals 2x plus 14. And that's how I can solve for x. And I know, yeah, 5x minus 19 equals 2x plus 14. Let's see. All right. That leaves me 3x equals 33. Yeah, 33. X equals 11. So I've got x equals 11. Okay. So 2 times, so starting with B, so 13 times 11 minus 35 is 108. C is 55 minus 19 36, obviously not to scale. And then D is 22 plus 14, which is 36. Oh, yeah. Well, at least I forgot that isosceles triangles, I only had to solve for one of these and they would be equal. Kind of proof of that point here. So let's take a look for a reality check. If I add 108 and 36, I should get 180. So 108 plus 36 plus 36, 180. Whew. And we're in good shape. For this last one, I've got WXY. Oh, here we are. This last one, WXY, angle X equals angle Y. So again, I've got an isosceles triangle, but instead of getting the sides, I'm getting the angles. So I want to make sure that if I'm going to get the two congruent angles, I want to put those down here so that my congruent sides are in the same position opposite the angles. So it's basically drawn the same way every single time. It just makes the problem so much easier. So that gives me 9x minus 11. xy is 4x plus 1. And then wy is 7x minus 3. So find x in the measure of each side. So 9x minus 11. So again, because I have it set up this way, I know that I'm going to pick these two. And it eliminates any source of error. It eliminates any possibility of error because I know these two are the ones that are part of the congruent sides because they're opposite the congruent angles. So 9x minus 11 equals 7x minus 3. That gives me 2x equals 8, x equals 4. Alrighty. So when it comes to wx, that's 36 minus 11. That's going to equal 25. And because it's isosceles, that's also going to be the side wy, 25. xy is going to be 4x plus 1, so that's 16, 17. Now, unfortunately, as I mentioned before, oh, here we go. Now you can see what I wrote down. As I mentioned before, the problem with doing isosceles triangles and sides is that sides can be anything. With angles, I can add them all up and get, with angles, I can add angles up as long as I want to, and I'll get 180 if I do them correctly. With sides, unfortunately, I don't have that measure of security. So I kind of have to hope that I set it up correctly and I did it correctly and I carried all the ones and did all the things. But that's why I've got my research assistant with me, and well, you should always have one with you also when you're doing this, even if it's just basic integer operations. No reason to mess up and have a source of error with that. So yeah, on to the next one.